So welcome back everyone after this break, and now is the time to discuss and solve the questions related to Black and Scholes model. Just have a look. Only 3 questions are there on Black and Scholes model. First thing, this is a formula based question. There is a logic to the formula, but it will take a lot of time to derive and discuss about the technicalities of the formula. Once you will look at the formula, you will realize that it is not worth paying so much of the time at this moment when the exams are near, and this is a fast track batch. So we'll be learning the formula. Second thing, it has been many attempts, no questions has been asked on the Black and Scholes model directly because of the subjectivity of the model. Because it says that take the formula, put the values, find out the answer. Binomial model is little practical, but this is also practical, but too much of, we can say, formula based or subjectivity is there. So we'll discuss the formula, we'll see how to use that. With practice, we will learn the formula and then we'll move ahead. Okay, let's find out the formula in the charts. When you go to this part, you will see this is a Black and Scholes model. Okay, understand, the base is same. When you started to calculate the value of the option, it was nothing but the difference between spot and strike price in case of call option. If the spot you wanted every time, in case of call option, you want the strike price to be lower. So if the strike price is, let's say, 100 rupees, and today the market price is 120, you will exercise this option. 120 minus strike price became the payoff, that is 20 rupees. In the very beginning, we took 20 as the theoretical market price, and then we realized that we have to include the time value of money. Then we started discounting this 20 rupees that was in the binomial model. And in this question, in this Black and Scholes model also, the base will remain same, that is S minus K, the spot price minus strike price for the call option. And what is for the put option? K minus S. Okay, let's take the call option now. Most of the questions will be based on the call option itself. Now you will see this formula. This is nothing but S minus K. Okay, this is the one part and this is another part. One thing. Now you will realize that what happens in the, let's say this is a timeline. The spot price today is 100 and let's say 120. And the strike price is, let's say, 100. So what does this means? It means that we can buy the shares at expiry at 100 rupees. So practically speaking, the 100 cash outflow, it doesn't happen, but if it has to happen, it is the cash flow at time expiry. So we cannot practically deduct 120 and 100 from each other because of the timing difference. Either you take 120 to the expiry or you take 100 to the present value. We are going to go with this model. We are going to calculate the present value of 100. How to do that? Sir, it's very simple. 100 divided by 1 plus R. It's simple. But what if the continuous compounding is to be used? This is a normal compounding. If you want to use continuous compounding, it is nothing but 100 divided by e to the power RT. Simply multiplying by e to the power RT, when you do it 100 into e to the power RT, that means you want to calculate future value. But if you want to calculate present value, you should multiply it with e to the power minus RT. We discussed this. And e to the power minus RT is also written as 1 divided by e to the power RT. Cool? Cool? See. K into e to the power minus RT. What is the purpose of e to the power minus RT? To calculate the present value of strike price so that we can deduct it from the spot price. Okay, sir. There are 5 portions or 5 parts of this formula: spot price, ND1, strike price, e to the power RT, and ND2. 3 has been discussed by us. Only 2 are ND1 and ND2. What do you mean by N? N is the normal probability distribution value of D1 and D2. ND1 and ND2, this is ND2. It shows, see, one thing, ND2 is being multiplied with the strike price. What happens at expiry, I will tell you. What happens at expiry with the option? There are two things that will happen. First, you will exercise the option or you will not exercise the option. There are only two things that is going to happen. If you exercise the option, there will be some payoff. But if you don't exercise the option, there is no payoff. So investor is more interested in knowing the chances of exercising the option. If there are two possibilities at expiry, there will be two probabilities as well of happening of this event, and investor is more interested in this probability. Let's say this is 70%, because if you do not exercise, the value of the option is 0. We don't want to calculate the 0 value, na? If we have to find out the answer as 0, then there is no need for the calculation. We have to come to a point or figure, and for that we have to for that it's very much important to know the probability of exercising the option. This ND2 in technical terms decides the probability, explains the probability of exercising the option. Okay, sir. Then what is ND1? Not exercising the option? No, sir. ND1 is called as the hedge ratio. You will learn about the hedge ratio later on. So these are the 5 items in the calculation of call option. Okay. Now I will just make sure. What if the value of the put option is asked in the exam? Sir, exactly you have to do opposite of this. See, start with K, because in put option the basic is K minus S. So start with K into e to the power RT, because whether you take call option or put option, strike price is exercisable at the expiry only, na? So bring the present value of that. So you start with K into e to the power minus RT, and then instead of taking ND2, take 1 minus ND2. The other side of the probability. The other side of the probability. Then minus sign will remain as it is. It is as it is here as well. S into 1 minus ND1. That's it. It's very easy. The formula is reversed, and instead of ND1, 1 minus ND1, instead of ND2, 1 minus ND2. The question is now how to calculate D1 and D2, and this is the formula for D1 and D2. Understand, D1 is also a part of the probability. D1 is nothing but natural log of spot price divided by strike price. I told you the natural log of a normal rate is results into continuous compounded rate, 9.98% if you remember, plus this is the spot price divided by the strike price, plus rate of interest, plus volatility, variance, this is the standard deviation square, variance of the stock divided by 2 into T. So if the rate of interest is given per annum, the standard deviation is also given per annum, and the call value has to be calculated for 3 months, then you will write 0.25. So automatically by multiplying the time with the bracket, you are converting the rate also in 3 months and the standard deviation also in 3 months. Then once you calculate and under root standard deviation under root T divided by standard deviation under root T. Once you calculate D1, calculating D2 is very easy. It is nothing but D1 that you calculated first minus standard deviation into under root T. So this is the subjective part. I'm not going much deep into it. But one more thing I will explain. What if the stock is paying dividend? If the stock is paying dividend, deduct it from the spot price. S minus dividend, present value of dividend, if it is in rupees or rate. But what if it is in yield? Then you have to multiply it from deduct it from the rate of interest. We did it in the futures price as well, R minus Y. In this case also R minus Y. That's it. See, spot price E into minus YT if the dividend is there, yield, and yeah, one more thing. If it is in rupees also, you will have to deduct it from this S as well as this S. Wherever the S will be used, it will be deducted. The dividend will be deducted from that. Okay, so this is the first impression of the formula. You are not expected to remember the formula. Do the practice, and even after that, don't pressurize yourself to remember this formula. There are lots of other things to learn in the entire syllabus. Let's move on for the questions now. I'm giving this one as homework. Sir, the very first question you are giving it as homework, because I'm going to take the difficult one as the class question. This one, question number 63. It is going to take a lot of time to solve this question because 4 times. This is as good as 4 questions. 4 questions. Okay, sir. Have a look. So 63 and 64 will be discussed by us. The shares of TIC Limited are currently priced at 415. This is current price, means S. And the call option, right to buy the stock, it will be exercised only when K is less than S. That's okay. Exercisable in 3 months time. Time is equal to 0.25 years. Remember this, 3 months means 0.25 years. Has an exercise rate of 400 K. Risk-free rate of interest is 5% per annum. And the standard deviation of the share is 22%. It's not variance, it's standard deviation. Standard deviation. Okay. Based on the assumption that the TIC Limited is not going to declare any dividend. This is not going to declare any dividend, so don't worry about the dividend. Over the next 3 months, is the option worth buying for 25? This is the actual market price of a call option. Premium. This is called as premium. So in order to buy this call option, you have to pay a premium of 25 rupees. Now the question is asking you whether this is the right price. Is it worth buying for 25? Now, how to understand whether this question is to be solved from the binomial model perspective or the Black and Scholes model perspective? Where the very first impression that will give you an idea that we have to take the Black and Scholes model approach in this question is the standard deviation. Standard deviation or the volatility was not there in the binomial model. Also in the binomial model, there is a concept of a price going up and down. Here, there is no such concept we have seen till now. So it is very clear that we are going to use the Black and Scholes model here. Let's solve this. Rest of the 3 questions we are going to solve afterwards. Question number 63. So the question is asking you to calculate the value of call option, means theoretical price. And the formula according to the Black and Scholes model is S into ND1 minus strike price into e to the power minus RT, to which I can write e to the power 1 divided by e to the power RT into ND2. Okay, let's put the values. Spot price is 415 multiplied by leaving the space for ND1 minus strike price is 400 multiplied by 1 divided by e to the power. Have a look. 0.05 is the rate of interest per annum into time 0.25 into leaving the space for ND2. Cool. This and this will be enough. Now let's calculate D1 first. D1, let's write down the formula. Natural log of spot price divided by strike price plus inside the bracket rate of interest plus standard deviation square divided by 2 into time and then divided by standard deviation under root t. So this will be like this you can remember only after certain practice. So natural log of spot price is 415 divided by the strike price, which is 400, plus rate of interest is 0.05, standard deviation is 22.22 square divided by 2.25 is the time, 3 months. Again 0.22 under root time, which is 0.25. This is how you have to write down. Let's solve this equation. This is going to be natural log of 415 divided by 400. That's 1.0375 plus 0.22 square divided by 2 plus 0.05 multiplied by 0.25. This results into 0.01855. Okay. And the denominator is 0.25 square root into 0.22. That's 0.11. Now the only thing that you need to find out is natural log of 1.0375. If the question is to be asked in the exam, they will have to give the natural log values. Obviously they might not give you the direct value of 1.0375, but they can give you the value of 1.03 and 1.04. By using those two values, you will have to do the interpolation. Remember that? And then find out the value of 1.0375. Let's do that. And for that purpose, you need a table. You need a natural log table. I will just give you this PDF. You can find this PDF in my Telegram channel as well. Just go to the Telegram channel CA Mayank Kothari and search for the Z table. Z table. Z space table. You will get the table. Otherwise also, if you don't find it anywhere, you can mail at support@conferenza.in. There also you will get the table. You can drop a message to me on Instagram as well, CM Mayank Kothari, and also you can WhatsApp me at 89834 So these are the sources. Why I am giving you so many sources is that sometimes it may happen that I'm not replying on a particular source because I'm not coming to that source for so many days. And in that case, you can go to you can use the other sources to get the PDF. Okay, so this is a natural logarithm table. Okay, there is a way to calculate natural logarithm on the calculator as well. Have a look. Natural log of 1.3. Let's say if we have to calculate natural log of 1.3, then what should be the calculator steps? Put 2.7183. This is the value of E. On calculator, press 12 times square root, then -1, press m plus, then 1.3, the thing in the natural log. Then press square root button 12 times, -1, then 3 buttons, divided by MRC and equal to. This will give you the exact value if you want to calculate that. Okay, but instead of remembering this much and giving a headache to yourself, it's good to go for the table values. Now we need the table value, natural log value for 1.0375, and we can see that we have 1.03 and then 4. So we have 1.03 and 1.04. These are the two values. We are not being given with 1.0375, so we have to do the interpolation. Okay, let's do the interpolation part now. Let's write down the value of 1.03 and 1.04. 0.029559. It's 0.029559 and 0.039221. And it's very simple. The difference between these two, the distance between these two is 0.01 steps. Okay. That means that if you move ahead or if you add this much of the steps in 1.03, you tend to add this much of the value in this base. So the base value is this. Calculate the distance between these two, 0.029559 minus 0.039221. So, okay, 0.029. Yeah, right. 559 minus 0.039221. So the answer is absolute value. Can I say that if I add this much steps in 1.03, the value of this much is to be added in this base value. But I don't want to move ahead or add 0.01 in 1.03. I just want to go from 1.03 to 1.0375. So practically if you add 2 more zeros here, you will see that from 300 to 400, if you move from 300 to 400, that's 100 steps ahead. So if you go 100 steps ahead, you tend to add this much value in the base. But actually your target is not to reach at 0.0400, but to reach at 0.0375, which is just 0.0075 steps away. So instead of moving 100 steps ahead, just go 75 steps and then find out how much value to be added in this. For 100 steps, this much is the value to be added in the base. For 75 steps, how much will be added in this? Again repeating. If you add 100 steps in 1.03, you tend to add this much value in the base value. But if you just move 75 steps in 1.03 ahead, then how much value to be added in the base? So you will start with the base value, which is 0.029559. Then since you have to add, because from 0.02 to 0.03 you can clearly see that we are adding, okay, plus 0.009662 is the increment in the value for 100 steps. Then how much will be the increment in the base value for 75 steps? This is called as interpolation. So this is what you have to remember. Okay, let's find out. Point 03681. Okay, let's write down and solve the question. 0.03681 plus 0.01855 divided by 0.11. So we have D1 ready with us. That's 0.5033. So this is D1. How to calculate D2? It's D1 minus standard deviation under root T. So 0.5033 minus 0.11. This is the value of D, standard deviation under root T. That's 0.392393. So these are the values. Can we write this D1 and D2 value in this question, in this equation? No sir, we cannot write the values of D1 and D2 yet in this question, in this equation, because these are only D1 and D2 and not ND1 and ND2. See, we have to calculate the normal probability of D1 and the normal probability of D2. So let's try doing that as well. This is the last step, ND1, before moving over to the main equation. ND1 means calculating n in bracket 0.5033. Again, now you have to find out the normal probability that goes into Z table, but in that also you will not be given with the exact value. So you will have to find out the values for 0.50 and the next value, which is 0.51. Because in between 0.50 and 51, 0.5033 is lying. Okay, let's go to this table. So if you remember the Z table, we have used this in the risk management chapter. Let me just remove all these things. Okay, so we have to find out 0.5033, right? So let's start with 0.5. And this is 0.50, the second word. 50 and 51 we need, right? So 0.50 is this one and 0.51 is this one. So first figure is replaced by this 5. So this is 50, 51, and we need that 0.50 and the next value is 0.51. We don't have the value of 0.5033 directly. So write down. Again, some kind of interpolation will be there. So 0.50 and 0.51. The Z table value is 0.6915 and 0.6950. You can clearly see that by moving ahead one or say 100 steps, you tend to add 35 points in the base value. If you go 100 steps from 0.50, 35 points will be added to this base value. So this is our base value, but we have to move to 0.5033 only, right? We can place it here as well. So to 0.5033 only. So how many steps are these? 0.0033. Now it's very simple. If you add this much value in the base for moving 100 steps ahead, then how much value will be added in the base for just moving 33 steps? So start with the base value 0.6915, and we know that we want to add. Sometimes it's deduction as well. Why adding? Because 6915 and 6950, it is going up. So 0.0035 is added to the base when we shift this much steps. Then if we move this much steps, that is 33 only instead of 100, how much should be added? That's 0.6927. So this is going to be our first value. This will be ND1. 0.6927. In the same way, you are going to calculate ND2. Let's do that once again. ND2 is nothing but calculating N in bracket D2, which is 0.3933. So 0.3933. Now in the table you will not get the exact value, but you can get this 0.39 and the next figure, which is 0.40. So let's write down point in here 0.39 and 0.40. This will mean that we are moving 100 steps ahead. Okay, but if we have to go only to 0.3933, that means only 33 steps. Then how much value? So let's find out the values of 0.39. 0.3, see, this is 0.3. 0.3 and the 9 comes to this part. This is 0.396517. 0.6517. Do you get that? Let's repeat it once again. 0.3 and this is 0.9. So 0.6517. 0.39. Okay, this will be replaced with the first number and then 39. Then what will be 0.40? Sir, 0.40 will be this much. See, 0.4. This will be 4 and this is 0. So 0.6554. 0.6554. Let's do that. That's 0.0037. So it's very clear. Now we can use it. This is the base value. Can I say that 37 points are added to the base value if I move by 100 steps? But if I want to move only by 33 steps, then how much value to be added? Understand the concept. Start with the base value 0.6517, then 0.0037 divided by 0.01 multiplied by 0.0033. It's very simple. Divide, then multiply. Okay, sir. That's 0.6529. So we have the second value as well now. 0.6529. So we have the two values. The first one is 6927 and the second one is 6529. Am I right? Yes, sir. So let's put these values because these are now ND1 and ND2. 6927, 6529. Okay, let's solve this question. Now it's very easy for us. That's 287.47 minus 400 divided by, how to calculate the value of E? 0.05 into 0.25, that means 0.0125. 0.0125. Put 2.7183 on the calculator, press square root button 12 times. Let's do that. Then minus 1, multiplied by what is there in the power plus 1 and then into equal to 12 times. Point 1.0126. That's it. Multiplied by 0.6529. Okay, so this is again 287.47 minus 257.91. So the theoretical value comes down to 29.56. This is C0, theoretical market price. Now compare it with the actual market price. Theoretically, the options value should be 29.56. This is how we have to calculate. A very lengthy procedure and too much of calculation. And that's the subjectivity that I was talking about, and that's why the institute has stopped asking questions on the Black and Scholes model. But that doesn't mean they are not going to ask ever in the exam. The chances are less because of the impracticality or subjectivity, but still it's a part of the syllabus, so no one can say whether they are going to ask or not. So this is the theoretical market price, which is 29.56, and if you go to the question, if you go back to the question, the actual market price is 25 rupees only. Have a look. So when the actual market price is 25, which is less than the theoretical market price, which is 29.56, what will you say? The call is undervalued. It's available at 25 instead of 29.56. So it's better to buy the call. It's worth buying the call at 25. Okay, sir. It's worth buying the call at 25, 29.60, and option is underpriced, hence it's worth buying. Okay, you have done with this. This is how you have to solve all the question. Let's have a look on the second part of that. Calculate the value of call option. Again the same thing, but this time the current price is to be considered is 380. They are only changing one thing, which is the current price, that is 380. So what difference it will make to the calculation? There will be something new that you are going to learn in this. When you do this, what will happen? I will tell you. When you replace 415 with 380, there will be some changes in the answer. I will show you. See. You will be replacing this part. You will keep 380 here. Okay. That's not a problem. The problem will start in this part. Instead of 415, you will keep 380 here. Okay. 380 divided by 400. When you do 380 divided by 400, it will give you the it will give you the value of 0.95. So the natural log that you will have to calculate is of 0.95. Let's do that. Second part. So D1 is equal to natural log of 0.95. Rest of the figures are same. So I will just copy paste it from the above and then I will move 0.01855. Okay. So this is 0.01855. Now let's find out the natural log of 0.95 in the table. If you will see, the basic table is starting from 1.0. We need 0.95. We need something with 0 point. So it's given on the last part of the table. This is the natural logarithm or table for the values of less than 1. So if you'll start with this, you will find 0.95 here. 0.95. All these values are in negative because 1.0. See, I will show you. Natural log of 1 is equal to 0. So anything, see, 1 is equal to 0. So anything less than 1, if you have to calculate, it will be negative. And this is 0.05129 negative. Okay, let's write down. Minus 0.05129. And then try solving this. So this comes to minus 0.2976. This is natural log. This is D1. How to calculate the natural log, normal probability of a minus value? D1 is coming to negative. That's what we are going to learn in the second part. And we will have to calculate the normal probability of a negative value. This is the reason I took this second part in the class itself, because we need to learn how to calculate ND1 of a negative value. Let's find out D2 first. D2 is nothing but D1 minus standard deviation under root T. It is 0.2976 negative minus 0.11. So it will again increase the value. That's minus 0.4076 D2. Now the D1 is this and the D2 is this. Can we find out the negative values in the Z table? No, sir. In our table, it is not given. I will tell you. It starts with the positive figures. It's not given in negative, but it is very easy to calculate the negative values. It's very simple, sir. If at any point of time you are calculating, let's say 0.25. So this value constitutes positive side, this value constitutes negative side. And the total area is 100%. What does that mean? Now you have to calculate the area of this side, negative wala. But the table values is given according to the positive side. So how to calculate this negative side? It's very simple, sir. Forget about the negative side, calculate the positive side first. And if it comes to 0.30, let's say for example, then deduct that from 1. Deduct that from 1. This is the 100% probability and the positive probability is 30%. Then negative will be 70% automatically. So how to do that? This is how we are going to do it. ND1 is equal to N in bracket minus 0.2976. Okay. Now reframe it. Convert it into positive figure. It is nothing but 1 minus N in bracket 0.2976. So now you have converted it into positive values, because ultimately you will be deducting the positive probability from 1 to arrive at the other side of the probability. And it's very easy for you to calculate 0.2976. Again, what are you going to do? Take 0.29. This is a positive figure now. Calculate the probability of a positive value, deduct it from 1 to arrive at the negative value. So 0.29 is already with you. Then you take the second figure as 0.30 and then do the interpolation. With this, you will get the ND1. And this, in the same way, you are going to calculate ND2. Okay, whatever value you reach at for this positive figure, deduct it from 1. See, if something is given in the syllabus, I'm not going to solve it now. I just wanted to tell you that if the D1 and D2 is coming to negative, how to solve it. See, now the D1 and D2 is coming to negative. How to calculate ND1 and ND2? They have not given the values in this question. So if you will calculate 0.2976, this is how you have to do it. 1 minus N in bracket 0.2976. So calculate the normal probability of 0.2976 as if the figure is positive and deduct it from 1, you will get 0.3830. They have done it directly, but this is how we have to do it. In this case also 1 minus N in bracket 0.4076. Calculate the positive value of the normal probability of this 0.4076, deduct it from 1, you will get this values. That's it. Simple and plain enough. Try once and let me know if you are facing any problem. Rest of the question is same. This is 10.52 that you are talking about. Okay. So this was the second part. In the second part, we learned about how to calculate the natural log of anything below 1, which will be negative, and how to calculate D1, ND1 and ND2 with negative D1 and D2s, okay, of the negative value. So that's why second part was also important. It taught us how to calculate the negative values. Okay. Third part, what would be the worth of a put option if the current price is considered to be 380? Now they want to calculate the value of the put option. How to do that? There is a formula ready with us. This is 380, right? This is 380. Okay. So in the third case, there are two different methods to calculate. In the third part, there are two different methods to calculate put option. One, you can go with the formula, or you can go with a new theory called as put call parity theory. So we are going to learn about this theory. But you can use the formula as well, which is nothing but k into e to the power minus rt. If you remember, k minus s is for the put option, the exact opposite of the main formula of call option. And then you will multiply it with 1 minus n d1, whatever that d1 is. Okay. Then minus spot into 1 minus n d2. I will tell you one thing. The 1 minus n d1 is not going to give you anything but the negative side of the probability. This is the negative side of the probability. Negative means whatever is d1 and d2, the opposite side of that should be taken here. Now what will happen, since you are taking the spot price as 380 itself, I will just give you an example. Let's say you will calculate the d1 of some negative xyz. Okay. How are you going to calculate? You are going to calculate it like 1 minus n of positive xyz, and that will come to, let's say, 0.40. Okay. So 40 is the value of positive xyz, but since it was negative, you will deduct it from 1 to reach at 0.60. Okay. This is going to be ND1 for you. ND1 for you to be kept in the put option formula. And when you go and put it in the formula, it will be like 1 minus 0.60 again. So ultimately it's coming to 0.40 itself, which was the first figure in this question itself, in this part itself, because of the negative D1. Otherwise it's okay. So this is how you have to solve this question with the formula, and the answer will be same as this. But now the major part is to understand the put call parity theory. Once you understand the put call parity theory, then it will be very easy for you to solve this question without so much of the calculation that you do in the formula. So let's take a break. Break means I'm not taking a break. Let's take a break from using the formula and focus on one theory called as put call parity theory. Now what is put call parity theory? It says that, the put call parity theory says that if the strike price of the put and the strike price of the call options are same, the maturity is same, then the option value of put and call, the option value and put and call should be at parity. Should be at parity doesn't mean that the option of value of the put should be equal to value of the call. No sir, I will tell you how to do that. Let's create two portfolios. This is going to be portfolio 1. Okay. The portfolio 1 is buy stock today and buy put option today. So let's say you are buying the stock at 100 rupees. So you have to pay 100 rupees, and you are also buying the put. Let's take the values as value of the put as 10. I might change some figures later on. I'm just taking it. So the total cash outflow to create this portfolio is 110. Do you agree with this? You have purchased the stock at 100 rupees and you have bought a put option. Put option means you can sell the stock in future at some exercise price. So let's say the exercise price is 110. So you can sell the stock at 110 if you want after 1 year. Let's say 1 year, straight away to make the calculations easy. Cool. You have made a portfolio like this at time 0, and let's say after 1 year, the spot price in the market goes to either 70 or 120. Let's take it as 90 and 130. What will happen? You have open position in both the market. This is the cash market. This is the derivative market. You will have to close the position in both the market. The stock that you bought earlier will be sold now. So you will sell the stock, sell stock. The moment you will sell stock, you will receive 90 rupees. In this case, if the price is 130, you will receive 130 rupees. But the put option, what will happen to the put option? You will settle the put option. Now tell me, you have the right to sell the stock at 110, and put option is exercised only when the strike price is greater than spot price. That means if the market price of the stock is 90, will you be ready to sell it at 110? Yes, sir. We are going to exercise the option. So the option will get exercised here and we will get a payoff of 20 rupees. Am I right? The difference between 110 and the spot price. We will get a payoff from the exchange of 20 rupees and the put option contract will get over. But if the market price goes to 130, we can sell it at 130. Why we would want to sell it at 110? A 130 stock nobody is going to sell a 130 stock at 110, right? So the option will not be exercised in this case and there will not be any payoff. Now both the options are expired, both the options are settled. You can clearly see the cash flows are 110 inflow, 130 inflow in both the cases. So this is the cash flow at expiry. And this is the cash flow at the beginning. So by creating a portfolio of 110 in the beginning, you let's reduce this value because 110 and 110 is being repeated. So let's take the premium of 8 rupees here. Okay. So the outflow will be 108. So can I say that by investing 108 at the beginning, I'm getting either 110 or 130. 110 being the minimum, because any price below 90 will result into the total inflow of 110. Whatever the stock price I will be selling at, I will get the rest of the amount in the put option as a profit. And if the market price goes up, I will get the higher price as well. 130, 150, 170 will be the cash flow. But if the price goes down, the cash flow is restricted to 110, 110, 110, 110. So 110 is the minimum amount that I will receive and there is no limit to the higher amount. Okay. So this is one thing. Second portfolio. Let's create a second portfolio. You know what? Why I bought a stock and then bought a put option? You would have said that we can buy the call option as well. But I will tell you one thing. There has to be a logic, right? Since you bought a stock in the market at 100 rupees, you are scared of falling prices in the future. And after 1 year, if the price falls to a great extent, you will be selling the stock. Understand? You will be selling the stock at lower price. You don't want to sell the stock at lower price after 1 year. That's why you are fixing the price of selling the stock today itself. You have already taken a long position in the stock. Why you would want to buy the stock again? You want to sell the stock that you have already bought. That's why put option is taken. If you buy the stock, buy put. That means if you buy the stock, buy the right to sell at a fixed price. Buy the stock, sell the stock. This is how the contract is closed. Na? So you have already bought the stock. For that purpose, buy the put option today so that you can sell it there. Okay. The next option is, okay, we are going to buy a call option here. What do you mean by a call option? Call option gives you the right to buy the stock. Now understand. If you are buying a right to buy the stock will be bought at this date, the expiry. Call option says that you can buy the stock at this date and the exercise price is 110 rupees. Okay. So you have purchased a call option. In that you can buy the stock at 110 after 1 year. So what are you going to do with that money? For the 1 year, at least you can invest that money. So invest so much of the money today that when you add interest for 1 year, it should be 110 rupees. So what will happen? I will tell you. You are preparing yourself for buying the stock after 1 year. So if you invest some amount, let's say XYZ, then for entire 1 year, the interest will get added to it. And after 1 year, you don't have to pay anything else from the pocket. The bank will give you 110 rupees. You give that 110 in the market and buy the stock because you have bought the call option. Okay. So what will be the current action for this? Invest present value of this price. invest present value of this price so that after 1 year it exactly becomes 110 and you can buy the stock with that money. So invest present value of strike price. The rate of interest is not given, na? Let's take the rate of interest as 12% per annum, or better to take 12% per annum. So what is the present value of 110? That's invest 98.21 rupees today. This will automatically become 110 after 1 year, which you will receive from the bank, and you can buy the stock at 110 if you want to. And let's say you are buying the call, that means you will have to pay the premium, and the premium amount is 5 rupees. What is happening is 98.21 plus 5. That's 103.21. And now let's find out what will be the settlement cash flows after 1 year, just like we did it in the previous portfolio. So this is a portfolio that we have created in which in cash position, in cash market, we have a investment position. We have invested the money, and in derivatives market, we have a long position on the call. Okay. After 1 year, the market can go to 90 as well as 130, the same as this, so that it will become comparable. Investment has nothing to do with the market prices. It will add interest in the investment and give it back to us. So this will be called as investment proceeds, which will be 110 in both the cases. I will receive 110 from the bank and the investment will get over. Now what will happen to a call option? The call option had a strike price of 110. That means you have the right to buy the stock at 110. When the market is going at 90, when I can buy the stock at 90, why would I prefer to buy at 110? Why would I want to buy at 110? So I will never buy the stock at 110. That means I will never exercise this option. So what will happen to the call option? It will not get exercised here and the payoff will be 0. But if the market price of the stock is 130 and I have the right to buy the same at 110, buy the same at 110 and sell it at 130, it seems profitable? Yes, sir. But this was not profitable. See, 110, buy at 110 and sell it at 90 rupees. This is not profitable. So that's why we didn't exercise. But selling at 130 becomes a profitable. So what will happen? We will exercise this option and I will get 20 rupees from the market. Am I right? 20 rupees from the exchange. How come 20 rupees? 130 minus 110. Buy at 110, sell at 130. So 20 rupees. So this is an inflow. Again, if you will see the total outflow and inflow, it is 110 and 130. So this is cash flow. So what is the similarity in both the portfolios? We have created 2 portfolios. What is the similarity in 2 portfolios? The cash flow at expiry is same no matter what the market price is. If the market price of the stock is 90, we are getting 110 in this portfolio and 110 in this portfolio as well. If the market price goes to 130, 130 and 130. The cash flow at expiry in both the portfolio is same. Now you tell me which type of portfolio you would prefer to create. An investor will go. All the investors will go for this portfolio. Why? Because since the cash flows at expiry are same in both the portfolios, it is a wise decision to invest lowest possible amount. If you have to create a portfolio and invest money, by paying 103 rupees, you are getting this cash flows, and by paying 108 rupees, you are getting the same cash flows. Why to pay more? Why to pay more amount for the same cash flow if we can get it at a lower investment? So all the investors will start building this portfolio. Because of that, what will happen? I will tell you. Because of that, the demand for the call option will start increasing. The demand for the call option will start increasing. Since the demand will increase, the option value will also increase. This 5 rupees will start increasing to such a level that this total becomes 108. what will happen? The demand for the call option will keep on increasing and the demand for put option will keep on decreasing because no one is ready to buy this to build this portfolio. So this will also decrease to certain level. So let's say for example this has come to 105, this will also decrease to 105. The moment they come to equilibrium, there will be an equilibrium, then the demand will stabilize. Otherwise the demand will shift to one side. It will be a one-sided demand which will affect the prices of call and put option in both the market. If there is no demand for put option, this price will start falling. If there is a high demand for call option, this price will start rising. And this will stop. This volatility in the prices will stop only once the prices or the cash flows in both the markets are same. When will be the equilibrium achieved? When the cash flow in building this portfolio and building this portfolio is same, because if the inflow at expiry is same, the outflow in the beginning should also be same in order to stabilize the demand in the market. Okay, otherwise no one will buy put option, no one will buy stock. Everyone would go and invest in the market at the present value of the strike price and everyone will start buying the call option. This will increase the demand of this. So when do you think the equilibrium will be achieved? When the cash outflow from both will be same. So this portfolio, so this portfolio should be equal to this portfolio. Let's write down. We will write down as like this. So buy stock in the spot market plus buy put, both will be outflow, should be equal to buy call plus buy present value of K, means investment. Okay. All of them are cash outflows. Understand, buy investment means putting money. So in variables, this is nothing but S plus P0. Value of the put option is the premium, that is P0, should be equal to C0, the value of the call option, plus present value of K. Present value of K. This is called as put and call should be at parity. Why the outflow of this should be equal to outflow of this? Because if it is not, if the equilibrium is not achieved, the demand will shift to one side. One thing will start, the demand for one item in this will start increasing and the other will start decreasing. So the amount, the values of put and call will go up and down and stabilize at a level when the equilibrium will be achieved, and that's why the outflow from both should be same. If the outflow from both should be same, that means nobody is going to shift and there will be a demand for both put and call option. Otherwise one of the item will not be sold ever in the market. There has to be a demand for both the things. Now there has to be demand for the stock also, put also, call also, and investments also. And for that purpose, this condition has to be achieved. Now, in this question, the third part, the question says that calculate the value of put option when the spot price is 380. So let's take the spot price as 380, value of the put option. What was the condition for put call parity theory? That the strike price in both should be same. Spot price in put and call should be same. So the strike and the spot price are same. That's why we are applying this formula. See, when the price is 380 and in this case also the price is 380. So I can take the call value from this part, which was calculated by us as 10.52. 10.52. So 10.52 is the premium of call option and the present value of K is nothing but 400 into e to the power RT. Yeah, this 1.0 e to the power RT 1.0126. You remember? 1 divided by 0.126. 1.01256 or 66. Yeah, like this. And then try solving it. this comes to P0 is equal to 25.54. You will not realize, but this is coming to 25.54. This will also come to 25.54. So even if you solve it through formula, it will come to 25.454. And if you go with this simple formula of put call parity theory, this will also give you 25.54, 25.58, 25.55, whatever it is. So all in all, this is very easy to calculate. But for that purpose, we should know the option value, right? Call option value. If you use this formula, understand, if you try to use this formula, then there is no need to have the call value as well in order to calculate the put value. But under the put call parity theory, if you want to calculate the value of put, you should have the value of call as well. That's it. This was the third part. Now coming over to the fourth and the last part. And that's very easy. The only one change that you need to incorporate is this. If TIC share price is taken as 408, now this is the new price, spot price. Earlier at the very first it was 415, then we took 380. Now we have to take 408. Also, if a dividend of rupees 10 is expected to be paid in 2 months time, whereas the option is of 3 months, then calculate the value of the call option. Again the same thing, except for some changes, which is like this. This is the timeline, 1, 2 and 3 months. 408 is here and you will be paid dividend of 10 rupees here. What are you going to do? There are 2 times S is used in the Black and Scholes model. So first of all, calculate the present value of 10, discount it by 2 months with the rate of 5% per annum. And then deduct that from 408 and use it as S minus present value of dividend, where in the formula of, see, only 2 places. One is here. Instead of S, keep S minus present value of I, and instead of S in the natural logarithm, keep S minus present value of I. So these are the 2 changes that you are going to do. 408 minus present value of dividend. Discount that 10 rupees by 2 months. And rest or everything is same. You won't face any problem. See, the present value of 10 is 9.917. And then what are we doing? 408 minus 9.917. This 398 is used in the natural log as well. And the value of the option as well. Rest everything is same. You have to do the practice in that case now. Okay, so this is the question. This is over now. Question number 64 is going to be the next question that we are going to discuss after a while. So I will take a break and I will be back with question number 64. This is going to be the last question on the Black and Scholes model. In this question also, we are going to discuss about one tail, two tail, and how to interpret the Z table. See you. Welcome back everyone. This is going to be the last question on the Black and Scholes model. In this question, we are going to use the same formula of the Black and Scholes that we have discussed in the previous question. But there is something new that we are going to learn, and that is about the Z table. How to read the Z table will be our purpose in this question. So let's start with it. From the following data for certain stock, find the value of call option. We have to find out the value of call option. The price of the stock now is 80. Exercise price is 75. And the standard deviation is 0.40. Time is 6 months. You can write it as 0.5 years. And the risk-free rate of interest is 12%, that is per annum. Okay, sir. Now, given number of standard deviation from mean Z, if you have to find out the value of ND1, that is 0.25, then area of the left or right one tail is given to you in this column. E to the power annual rate 0.12 into half year, because we want to calculate the value of the call option for 6 months, is this. Natural log of 1.0667 is this. Everything is given to you. You can see that natural log of S by K is the formula for calculation of the D1. Then it will be 80 by 75, which will come to 1.0667. So this is also given to you. This is also given to you. The major part to learn in this question is the how to interpret the Z table. Everything else is the same as the previous question. So we'll start this question with the basic formula of S into ND1 minus K into e to the power minus RT into ND2. So that's the basic formula. Then D1 and D2, the same formula. We'll start putting the values in D1 and this is what we are going to reach at. Natural log of 1.0667. Then you can clearly see that this is the annual rate. This is nothing but standard deviation square divided by 2. So 0.4 square divided by 2 will be 0.08. Okay, so that's 0.08. This is half year, right? And in the denominator, standard deviation under root t. Cool. So when you solve this equation, you reach at D1 of 0.5820 and then the D2 is 0.2992. Now you have to calculate ND1 and ND2. That's the major task, and for that purpose you will have to use the Z table. You will try to find out these values in Z table, and the table is already given to you in the question. In exam, if they're gonna ask this question, be assured that you will not be given with the entire Z table. You cannot also carry the Z table with you. So all the values will be given in the question itself, but you need to you need to understand how to read Z table. Okay. Let's first go to the Z table. Yeah, this is the Z table, and understand, take any value. Let's say we take one standard deviation, Z. In the Z column we take one standard deviation and the area is 0.8413. The area for one standard deviation means, understand, it means from when you stand here and this is one standard deviation, it means the entire area. So this is 50%, this is also 50%. We have seen this in the risk management chapter, that equally both the areas, both the sides have been divided. So 50% probability on the left side, 50% probability on the right side. And whenever we calculate the Z table in the cumulative probability, so what happens is that we are not calculating only this much area. No, we are not doing that. We are actually calculating this much area. When we say one standard deviation, the entire left hand side will be added. So what happens is that we start with 0.50 itself, because from this point we are going to move one standard deviation on the right side, and this point starts with 0.5. This entire area we are considering the 50% probability already of the left side. So whatever will be the value on the right side of 0 to 1, see, if you calculate the probability of 0 to 1 standard deviation, it will be something like 0.3413. Okay, this is only one tail, one side. But if you calculate cumulative probability, then you will add 0.5 to 0.3413. That means you are going to take this entire left hand side, that's the 50% probability, and 0.3413 probability of this. So it will be 0.8413. So do you realize how this 0.8413 is calculated now? 0.8413 covers the entire left hand side. Okay, any side you can take. If you want to calculate -1, then this will be the area. Then entire right side will be covered. Okay, let's first find out +1. So 50% of the entire left hand side and the difference, the probability of 0 to 1, 0.3413. Okay, let me just take you to the online calculator. If you want to do some research on the Z table, you can go through this amazing website, which is mathsisfun.com, and you will see this amazing table here. Now let's understand these figures first. 0 to Z, up to Z, and Z onwards. 0 to Z, up to Z, and Z onwards. So this 0 to Z, Z is the standard deviation that we are seeking the value for. Okay, so if we want to go to one standard deviation, 0 to 1 will be the answer. Now you can clearly see that this table is giving us, this diagram is giving us the probability or the area covered between 0 to 1 in the probability, this bell-shaped curve. 0 to 1 is 34.13%. Okay. Now you remember, you know that left hand side covers 50% of the probability and right hand side covers 50% of the probability. If we have to find out the normal distribution of 1, then 34.13 is not the answer. You just go back to this table, Z table. This is a cumulative probability table, and this is what is used in the Black and Scholes model. And if you take one value of 1 from this table, this is 0.8413. So if value of 1 is 0.8413, why the value of 1 here in this diagram is 0.3413? Because this is not giving you the cumulative values. This is just giving you one-sided value. Cumulative value include, if we want to calculate the cumulative value, then we have to shift from 0 to Z to up to Z. Up to Z will start the area from this point till 1. So what will happen? This 50% of the left hand side, which is not covered right now, will also be added to 0.3413. You just do that. 0.50 plus 0.3413. This will be 0.8413, and that is our value. So it is very much clear that the Black and Scholes values that we need is in the second category, that is up to Z. Up to Z. Have a look. So if we go for up to Z, you will get exactly the value that is given in the table. So this is what we need. The previously also we found the probability for 1, Z is equal to 1, Z is equal to 1, and now also we are finding the same thing, but it depends upon where you are starting from. Let me just take a screenshot of this and I will just show you. Before this I started from this area, so it was giving me this much of the probability, but this is not what we use in the Black and Scholes model. The Black and Scholes model will use this entire area. Okay. Now you remember one thing, you have to remember one thing, that we have to use this much of the area from up to Z area in the Black and Scholes model. So even if this is given to you, you are going to add 0.5 in that. If it is not given to you as a cumulative figure, you will have to add 0.5 to make it to 0.8413. There can be 3 to 4 different ways of giving you the values for the standard deviation or Z, and you will get confused with each value. Let me just go to, I will explain every part of it and then we will shift to the question. Question number 64. I will take the simple example of, let's say we have to find out D1 for 1 and ND1 for 1. That means we have to find out normal probability for 1 standard deviation. That's okay. Now understand, the table values that can be given to you is non-cumulative value for 1 is 0.3413. Cumulative value for 1 is 0.8413. Cumulative means we add the other half also in this value. So 0.5 plus 0.3413 will be 0.8413. Also they can give you one tell. One tell means the other side of the story. See, this is Z onwards. Okay, if you have been given with this figure and you calculate 1, so this is one tell. Tell means the end part, the other part of that. This is a tell side. If you are standing like this, see, if I am standing like this, what I need is the body part, and this is the tell part which has been given to me. What I need is the body part, and this is the tell part which has been given to me, which is 15.87%. So one tell value of Z score 1 is 0.1587. Okay, sometimes they will give you 2 tell values, and the 2 tell values for 1 standard deviation is nothing but, see, 2 tell means from this area to the entire right hand side, and from, I will just show you, this area to the entire left hand side. So this is one tel and this is second tel. Or let me just take a screenshot of it and I will show you what is two tel. Two tel is the value in this area and value in this area. So again they will give you they might give you two tel value of 0.15 1, which is 0.1587 into 2, that will be 0.3174. Now you can clearly see that all these are the z values, the probabilities of standard deviation of 1, but everything depends upon this. And remember, in the Black and Scholes model, the only thing that you need is the cumulative value of standard deviation or 1. Cumulative value of 1. That's it. If they are giving you 1 tel values, how to calculate the cumulative value? It's very simple, sir. See. So this is the 1 tel value. If they are giving you 1 tel values, how to use this? We don't want 1 tel value or the tel value in the Black and Scholes model. All we need is this area. How to calculate that? You remember the entire area is 100%. So you deduct 0.1587 from that to reach at the cumulative probability distribution. So in order to reach at the cumulative probability distribution, what you can do is, for this 1 minus 0.1587, this will give you 0.8413, and now you can use it in the table. If they are giving you two tel values, so first what are you going to do? You will convert 2 tel divided by 2 to 1 tel, and then 1 minus 1 tel value will give you the body value. So let's try to solve it. 2 tel value is 0.3174 divided by 2. This 1 tel and the 1 tel. We don't want this area, right? If you have been given with this and this area, you don't want this area in the in the normal probability distribution. What you want is this much area. So how to do that? First divide the 2 tel by 2 and you will reach at this point, and then deduct this area from 1. So 0.3174 divided by 2 is 0.1587. Now you have converted the 2 tel in 1 tel and then deduct that value 0.1587 from 1 to reach at 0.8413. Ultimately, this is the only value that you have to keep in the equation. And if the non-cumulative value is given to you, simply add 0.5 to that value to reach at 0.8413. So in all the parts, we need 0.8413, 0.8413, 0.8413. So there can be 4 to 5 different ways of presenting the ND1 values or the probability Z table values. You have to make sure that you are taking only the cumulative values in the equation. Do you understand that? And that's what has happened in this question. I will show you. You can clearly see that we need a body value of 0.25. Understand? If I'm standing like this, okay, this is my body part and this is my tail part. We need the body part. This is the cumulative area. We need the body part, but the tail values has been given to you, and that too only one tail. So this is the other side of the story. 0.25. Have a look on this table. So 0.25 comes to here. So what is the probability of 0.25? 59.87, but what is given here is 40.13. What is that 40.13? I will just show you. This is what the value required in the Z table, but they have given the exact opposite of that. The other side. Have a look. 0.25. See. What they have given is the second part of that, but when where we want this one area, right, this side of the area. So how to calculate the body part? It's very simple, sir. All the figures, this is one tail, all the figures will be deducted from 1 minus 1 minus 1 minus 1 minus, and we will get the cumulative area that we can keep in the equation. So 1 minus 0.4013 is 0.5987. This is what you have to use for 0.25. There can be different ways to present the values of 0.25, Z values of 0.25. So you should be very careful before picking up the values. Lots of students will do the interpolation for 0.4013 and 0.3821. No sir, these are the tail values. This is not required. We need the body value. This is the timeline. Okay, this is the entire area 100%. I'm just summarizing this. When the question says to take the Z value till 1, you should keep this value in the equation. But if they have given you this value, then what is the solution? This is the one tail value. Then what is the solution? Deduct that from the entire area of 1. So when you deduct 1 minus this tail, you get the body value that you can keep in the equation. So that's what you have to do. You can see that the very first part that you have to calculate is 0.5820, and understand 0.5820 comes in between these two values. So you will have to interpolate at this 0.55 and 0.60. 0.5820 comes in between this, so interpolate this, but don't use 0.29 and 0.27. Use the exact opposite of this, 1 minus 0.2912. Use the body values in this case, that is 0.7088, and 1 minus 0.2743, that is 0.7257, and then interpolate these values. These are the body values or the cumulative values that we normally keep in the Black-Scholes model. This is not what we use. So you will realize that when you interpolate this, the answer will come in between 70 and 72. Have a look. See, ND1 is 0.7197, sir. So it is between that. Na? These are the cumulative values. Okay, sir, that is what I wanted to tell you. What if the two tail values have been given? Two tail values will be exactly the double of this. So instead of 0.4013, it will be 0.8026. If the two tail values are given, what is the solution? Simply divide it by 2 to convert it into one tail, and then deduct it from 1 to convert it into the body value. So keep this formula in your mind. I will just write it down. For the Black-Scholes model, we need cumulative figures, cumulative body value. So body value is equal to 1 minus 1 tail value, or 1 minus 2 tail divided by 2. Simple enough. What you have to do is, you can convert 2 tail divided by 2 into 1 tail and then deduct it from 1 to arrive at the body value, and then use it in the Black-Scholes model always. The fourth part was non-cumulative. So in that case, body value will be 0.5 plus non-cumulative figure given to you for one standard deviation. So you should add the rest of the 50% area in the non-cumulative figure to reach at the cumulative figure, and that's when you will get the correct answer. Okay, sir. Question number 64 is now over. You can do rest of the questions. You can solve rest of the questions. See, this is the cumulative area, and you can see that it is 0.8026 because it is 2 tail. So what you are going to do is divide it by 2 and then deduct it from 1. You will get the answer. Okay, so with this we finish our syllabus for the Black and Scholes model, or the course for the Black and Scholes model. There are a couple of more concepts left. The concept that we are going to discuss here for the calculation of the option value is, which is more or less the binomial model itself, is the portfolio replicating model. Portfolio replicating theory is another theory that we are going to discuss. I will just take a break of 5 minutes and I will be back to discuss that theory. See you. Let's start with the discussion of a new concept, that is portfolio replicating model. Okay, sir. Now understand the theory. Let's take the spot price of the share as $50, and this particular theory is more or less connected to the binomial model. Okay, so we are going to take it in that way. So what happens in the binomial model is, there is one concept called as the prices moving up and down. What happens in the binomial model is, we assume that the prices will either go up or down from this level. So the upper price, let's say it can go to 60 and it can go down to 40. Take the rate of interest as 10% and time as 1 year for the sake of simplicity in our calculation. Okay. There is one call option also available at a strike price of 55. Okay, you will have to pay the premium for that. Obviously, if you want to buy the call option, you will be paying the premium. Let's say the premium is 4 rupees. So this data is given to you. Now, let's do one thing. This is going to be portfolio, and just pay a close attention to what I'm doing. At time 0, I am buying the stock. How much stock? Sir, 0.25 stock only. Sir, how it is possible to buy 0.25 stock? It is not possible, because the stocks are purchased only in the whole number, either 1 share or 2 share. What is 0.25? You cannot buy 0.25 share. Exactly right. I cannot buy 0.25 share, but it is only taken for the purpose of theory. So whenever I say 0.25 share, that means I'm talking about 1 share for every 4. 0.25 for every 1 means 1 share for every 4 units. Okay, I will talk about it later. How did this 0.25 come from? I will just discuss that later on. So this is our question first. Now, if you buy 0.25 share, what will happen? If you go and buy the entire share, it will cost you around 50 rupees. But if you just buy 0.25 share, it will be 0.25 into 50 rupees of the outflow, which will be 12 rupees 50 paisa. Am I right? Okay. Then you do one thing. You borrow something from the bank. Let's say you borrow 9.09 rupees. Okay. Now, there are two questions in your mind. What is the calculation of 0.25? Where did this come from? And what is the calculation of this 9.09? These are the two things we are going to discuss at the end of this entire concept. But for now, let's just imagine that if we create a portfolio like this, the net investment in the portfolio is 12.50 minus 9.09. That's 3.41 rupees. So can I say that I can create this investment, this portfolio, by just investing 3 rupees 41 paisa, because 3 rupees 41 paisa is my own investment. I have borrowed 9.09 rupees. The total is 12.50, and I bought 0.25 stock with that amount. So this is how I have created a portfolio. Now let's say after 1 year, 1 year, what happens is the stock can go to 40 or it can go to 60, up or down. Now we are going to settle all these situations. We are going to close the situation and we are going to find out what is the profit or loss. So if we have bought the stock at time 0, we will be selling the stock. And understand, we have bought only 0.25 of the stock, so that we are going to sell only 0.25 of it, right? So when you sell 0.25 of the stock, 40 multiplied by 0.25 will be your cash inflow, that is 10 rupees, and it will be 12 rupees in this case, sorry, 15 rupees in this case. 60 multiplied by 0.25. You are not selling the entire stock because you have not purchased the entire stock. You purchased only this much and you will be selling only this much. Okay, sir. Then what will happen to the borrowings? Borrowing is like irrespective of the spot prices, the borrowing will be like we are going to add interest in the borrowing irrespective of the spot prices on that date. So we will be paying it with interest. Repayment 9.09 multiplied by 10% interest, 1.10 comes to 10 rupees. So you can clearly see that the cash flow in the first part is 0 and it's 5 in the second part. Cool, sir. So can I say that by investing 3 rupees 41 paisa, I can either get 0 rupees after 1 year or 5 rupees after 1 year. So this is a situation after 1 year. Now the last part. Let's create a position in derivatives market. At time 0, do one thing, buy call option. When you go to buy one call, that is at a strike price of 55, it will cost you around 4 rupees. Am I right? Okay, sir. And then leave the position. Come back to the market after 1 year. The price will either go to 40 or 60. What will happen? You have the right to buy the stock at 55. You have the right to buy the stock at 55, and in this case when the market itself is going at 40, the situation is strike price is greater than spot price. We are not going to exercise the option. The cash flow will be 0, right? Because market is giving the stock at a cheaper rate. But in case of 60, you can clearly see that the cost is less than the strike price is less than spot price. We will exercise the option and the cash flow will be the difference between 60 and 55, that is 5 rupees. Okay. So can you see one thing, that in both the positions, in whether we create a portfolio or we create a call option, the cash flow at expiry is same. Okay. So from the angle of the investor, you tell me one thing, which type of position you would prefer to create? Obviously, all the investors will go for this type of a position. They will create a portfolio instead of buying a call option. Why? Because by paying 3.41 rupees only, they can get 0 and 5 at expiry or after 1 year. When it is confirmed that we will get 0 and 5, why we will pay 4 rupees when we can do the same thing or achieve the same cash flows at by paying 3.41 rupees only? So this is where what will happen, the demand for the stock will increase and the demand for the call option will decrease. Nobody is buying this call option because of this type of a portfolio. Nobody is buying this call option. That means the demand will decrease and it will keep on decreasing until and unless the options value, understand, the options value becomes 3.41. When the options value will be 3.41 now, the demand will stabilize. Okay, let's assume that the options value is 3 rupees. Now what will happen? Everyone will start buying call option and nobody will be creating this portfolio. So the demand for the option will increase. The demand for the option will increase, resulting into the increase in the value of the option. So this 3 rupees will keep on increasing because of the higher demand and it will stabilize or stop
when it comes to 3.41. So this is what is going to happen. Because of the low demand, the price will fall from 4 to 3.41, and because of the high demand, it can go to 3.41 from 3. It can go from 3 to 3.41. So in order to stabilize the demand and achieve equilibrium in the market, the cash outflow of this portfolio should be the value of the call option. So we have another method to calculate the value of the call option, which is nothing but creating this portfolio. This is what we say portfolio replicating model. Means we can create a portfolio which will replicate, which will give us the mirror image of the value of the call. So the outflow in creating this portfolio should be the value of the call option. That's what is the theory. Otherwise, if the values are not same, otherwise because of the demand, the prices of the options will go up and down. In order to stabilize the market, in order to achieve the equilibrium, the options value should be equal to 3.41. That means it should be equal to the total of these two. So therefore, options value is C0, in this case call option, and it is nothing but 0.25 multiplied by 50 minus 9.09. 0.25 is called as the hedge ratio. The other name for this is called as delta, and the symbol is this. Okay. Hedge ratio multiplied by the spot price, minus borrowings. What is the borrowing? This 9.09 is the borrowing. So this is what your C0 should be. So in order to calculate the value of the call option today, it should be exactly equal to the amount of investment required in creating this portfolio. Because if it is not equal to that, then the options will either fall in the demand or increase in the demand. If the demand falls, the value of this option will keep on falling, and it will stabilize only where it comes to exactly the investment in this portfolio. Do you understand that? This is a spot market, this is a derivatives market. You can create this type of a portfolio which will give you the exact cash flows which the options can give, which the options will result. If the options can result the same cash flows at 4 rupees, everyone will keep on buying the portfolio and no one will buy the option, because option requires higher investment for the same cash flows. No one will pay more for the same cash flows, and the demand will decrease, resulting into the decrease in the options value, and then it will stabilize at this from 4 to 3.41. Okay, now there are only two questions. Call option, so we have to calculate. Spot price will be given in the question. There are only two questions that you are worried about: how to calculate this delta, that means 0.25, and how to calculate this borrowing. And there is a formula for this. Understand? The delta is nothing but the difference between the options value at upper and lower level divided by the difference between the stocks value at upper and lower level. You just imagine if you are standing here and the prices can go from 50 to 60 and 40, and the strike price is 55. So what will happen? At this point the option will be exercised, at this point the option will not be exercised. If it gets exercised, you will get 5 rupees, or in this case you will get 0. And this is SU, this is SD, the difference between these two is 20. And this is CU, this is CD, the difference between these two is 5. If you keep that in the formula, 5 by 20 is equal to 0.25. This is how we calculated 0.25. Understand? This 0.25 is calculated with the help of the given data itself. We needed the options strike price to calculate 0.25. Understand this. This is how we calculate. This is the delta. This is hedge ratio, which is achieved by the difference between the options value in the numerator divided by the difference between the stocks value in the denominator. So this is one formula. Now let's talk about the borrowings. The minimum amount that you need to borrow is nothing but the SD, the lowest possible spot price after a year is 40. Lowest possible, because this is the minimum amount required to be borrowed. Minimum side it can go to 40. So 40 SD multiplied by delta. Since you are buying only 0.25 of the stocks, not the entire stock, why to borrow the amount equal to entire stock? Just borrow the amount equal to the lowest possible stock price. Okay, this is SD minus delta, SD multiplied by delta minus CD, call value if any. So what are we going to do? That we will be selling the stock at lowest possible price of 40 after a year. So this will be our inflow. Plus, if we buy the option and if there is some cash flow here, if we exercise the option at this point, there will be some inflow here. So we will reduce that amount required from the borrowing. So minus this inflow. Most of the time CD will be 0. Most of the time the CD will be 0, but not all the time. Sometimes CD also has some value. So lower price of 40 multiplied by the delta minus the call value at lower level divided by 1 plus R, or if the continuous compounding is used, e to the power RT. This is the amount of borrowing. This is the present value of that amount. So present value of that amount. See, SD is 40, delta is 0.25, CD is 0 and 1.10. So this is nothing but 10 divided by 1.10, 9.09. This is how I calculated the borrowings required today. What happens is that in the time frame, 40 multiplied by 0.25 is the cash flow here. And if I'm borrowing it today, I'm making sure that 9.09 is the amount that I borrow. Why? I will tell you. See, understand. If I borrow this much of the amount, it will become 10 rupees after a year. So I will have to repay this 10 rupees. And from where did this 10 rupees is going to come? By selling the stock at the lowest price. Understand? I'm buying the stock today. After a year, either I will sell it at 60 rupees or I will sell it at 40 rupees. If I sell it at 60 rupees, so 60 multiplied by 0.25, I will get 15 rupees. That's well and good. Okay. But if I sell it at 40 rupees, the minimum that I will get at the expiry out of 10 and 15 is 10 rupees. So I'm borrowing only that much, which I will be sure of getting the cash flow by selling the stock after 1 year. The purpose is very simple. Borrow today only the amount which you are sure of repaying, that you will be able to repay. You can repay 10 rupees in this case also and in this case also. But you cannot repay 15 rupees out of 10. Understand? So that's why we are taking SD, the lowest possible price that we are going to receive. SD is the 40 into delta. That means 40 into delta, 10 rupees is what you are going to receive by selling the stock at expiry, and the same present value, after converting it into present value, we are borrowing the same amount. Are you getting it? Okay, sir. So 9.09 is the borrowing. This is how you have to do the calculation. Summarizing everything, I can just write down here. Have a look. Call options value is nothing but S into delta minus borrowings. Delta is nothing but the difference between the call options value divided by the stocks prices at upper and lower level. And borrowing today is nothing but the lowest possible price at which you can sell the stock multiplied by the stock that you have bought minus the call option value at lower level, if any, divided by 1 plus R. So you will borrow only the amount that you are sure of repaying at the expiry. So this is how you have to use the portfolio replicating model. Let's have a look on the question now. Question number 65. Mr. Dayal is interested in purchasing equity shares of ABC Limited. You can clearly see that Mr. Dayal wants to buy equity shares of ABC Limited, which are currently selling at rupees 600. So let's do the calculation. This is question number 65. So currently the prices are like this, 600. he expects that the price of the share may go up to 780 or down to 480. Okay. Then in 3 months time, this is entirely 3 months period, the chances of occurring such variation are 60 and 40% respectively. So practical probabilities are given to you, but you may not use it. Let in the binomial model, if you go with the binomial model, the probability has to be calculated in this manner according to the risk neutral method. 60 and 40 is the probabilities given according to some other analysis. Okay. A call option on the shares of ABC Limited can be exercised at the end of 3 months with a strike price of 630k. Okay, 630 is the price. Good enough. Now, first part, what combination of share, that means the delta, how much share, how many shares, and option should Mr. Dayal select if he wants a perfect hedge, perfect hedging. Okay, let me just discuss or explain this to you. See, this is a situation of perfect hedging, that in both the cases nobody is having a what we can say preference. What combination of share was there? 0.25 against one call. This is the combination. Buy 0.25 share against every call. So if you want to buy 4 calls, 4 into 0.25, you will have to buy 1 share. So 1.25 share, buying 0.25 share and selling 1 call give you the perfect hedge. Hedge means no profit or loss. So in one market there should be a profit, and in the another market there should be the same loss. So if you, instead of buying a call, if you sell 1 call, the same will be your outflow, 0 and -5. 0 and 5 will be your inflow, 0 and 5 will be your outflow. And this will be resulting into 0 profit or loss. That's called as hedging. So how did you create a hedged position? By buying 0.25 stocks and selling 1 call. Don't buy the call if you want to create hedge. What happened in this case? Let me tell you. You bought the stock and you bought the call. So the total profit is 5 and 5, 10 rupees. This is not hedging. Hedging is where the profit or loss is 0. So one should be profitable situation, the other should be a loss situation. In order to reach a loss at this point, we will have to sell the call. Either you sell the call, or either you do one thing. You sell the stock and do the investment. Do the exact opposite. Take the opposite position in both the markets. So buy the portfolio and sell the call is a better option. If you sell the call, you will have to make payment of 5 rupees to the buyer of the call option. So this will be your outflow and this is your inflow. Net is 0. 0 and 0 is 0. 5 and -5 is also 0. So buying 0.25 stock and selling 1 call will be the answer for perfect hedging. Okay, I'm just repeating once again. They are saying what combination of share and option. So let's find out. The very first thing that they are asking is delta, which is nothing but CU minus CD, SU minus SD. So CU, let's say, are you going to exercise when the stock price is 780? Yes, sir. I can buy the share at 630 rupees. Why I will not exercise the option when the market is at 780? I will exercise the option and I will get 150 rupees as the payoff. 780 minus 630. 780 minus 630. This will be called as CU. This is SU. But when the market price is 480, why I will sell the why I will buy the share at 630? No. When the market is at 480, I will prefer to buy at 480. Why I would go for 630? So I will not exercise the call option and the options value will be 0 here. This is CD, this is SD. Let's find out the difference. 150 minus 0, 6, 780 minus 480. That's 150 divided by 300 and 0.50. That is buy 0.50 stock and sell 1 call, or buy 1 stock or sell 2 call options for perfect hedging. What does that mean? It means that if there is a loss of X rupees in this situation, it will be the profit in of the same amount in this situation, or if there is a loss of X rupees in this situation, there will be a profit in this situation of the same amount. That's where we call it as a perfect hedging. There should not be a loss and loss or profit and profit. That's not hedging. Hedging is profit and loss of the equal amount. That's why I told you, instead of having a positive cash flow here, you need a negative cash flow. Loss and profit. That's when the hedging situation is created. And for a negative cash flow, you need to sell the call, not buy the call. So that's what we are saying. Delta gives you the ratio of how many shares you have to buy for every sell position, every one sell call position, for selling one call option. So if you want to double this, you double the stock as well. See, 0.5 share for every one call option. You will buy it, you will sell it, you will go long, you will go short in this. Okay. Second part. What should be the value of the option today? They are saying call option. How to calculate that? It's very easy, sir. Second part. You can calculate this answer with the help of either binomial model or the portfolio replicating model itself, which says that delta into S minus borrowings. This is the formula, right? Delta is 0.50 and the spot price is 600. Okay. And minus borrowing. Borrowing is nothing but SD into delta minus CD divided by 1 plus R. So this is 300 minus SD is 480 into 0.50 minus CD is 0. Am I right? The call value at lower level is 0. Only 50% of the lowest possible amount is required to be borrowed, and the present value is 1. See, the per annum rate is 10% and we have the 3 months rate only, the 3 months options only. So 1.025. For 3 months, the rate of interest will be 2.5%. 300 minus 234.15. That's 65.85. The value of call option. So this should be the value of the call option. Understand what will happen if the call, this is the theoretical market price. Now let's say the actual market price is 70 rupees. What will happen? Please understand, nobody will buy the call option because the cash inflows or the payoff by investing in the option after 3 months will be exactly equal to the payoff from this portfolio. So if I'm going to receive the same amount by creating this portfolio at 65 rupees, why I will get the same amount by buying the call option at 70? Paying higher amount for the same payoff at the expiry is not desirable to any investor. So no investor is going to buy this call option, resulting into the fall in the demand of this call option, and the fall in the demand will result into fall in the prices of this call option, and 70 will come down to 69, 68, 67, 66 and then 65.85. It will stabilize at this point. Okay, if you say that the actual market price can go to 60, then what will happen? Let's say, for example, by exercising this call option after 3 months, people are getting 100 rupees. And in this portfolio also after 3 months, people are getting 100 rupees. So the inflow after 3 months in both the possibilities are same, that is 100 rupees. So why anyone will pay 65 rupees for 100 when they can pay 60 rupees and buy the call option for 100? Every investor will start buying this call option. Okay, every investor will start buying this call option, resulting into the increase in the demand of the call option, resulting into the increase in the price of this call option, and it will stabilize at 65.85. That means the moment, see, it will happen like this. If it is 60 and 70, or if it is 70 and 60, what will happen if the options value is this? the demand will fall for the option, and let's say it is reaching to this 65.85. Once it reaches to this point, the demand will stabilize, but once it goes down from 65.85, the demand will again increase and this will stabilize at this point. So if the price is above 65.85, the demand for the option will fall, resulting into the fall in the prices. So this is the answer to your question. Now the third and the last part of this question. What is the expected rate of return on the option? If we want to calculate the rate of return, that means we are investing in the option. Investing means we are going long in the option. That means we are buying the option. Okay, and just talk about the option, nothing else. They are just asking you the return on option, not the entire situation. And the answer is very easy, sir. Investment in the call option today is equal to C0, which is 65.85. Let's say you have bought the option, you have gone long on the option. Now what will happen after 3 months? After 3 months, let's calculate the payoff. You can clearly see that after 3 months, the prices can go up to 780 or 480. So the price can go to 780 or 480. If the price goes to 780, you will exercise the option and it will result into a payoff of 150. If the price goes to 480, you will not exercise the option, the payoff will be 0. There is a 60% chances for 150, I think so. Let me just cross check. And there is a 40% chance for 0 rupees, resulting into 90 plus 0. That is, the net payoff is 90 on this date. So what is happening? You are paying 65.85 rupees today and you are getting only 90 rupees after 3 months. Can we calculate the return? This is our cash outflow and this will be our cash inflow, isn't it? So if the cash outflow is this, cash inflow is this, can we calculate the return? Yes, sir. Return is equal to return in the numerator, which is 90 minus 65.85, and investment in the denominator, which is 65.85. 90 divided by 65.85 minus 1. That's 17 point. Okay. 36.67%. This is what we earned. Or you can simply say that the options value when we purchased it 65.85 and on this date it is the options value is 90. So the balance is your profit. Don't ask this question that how can we compare 90 with 65.85. We are not comparing. We are calculating the return, and return is calculated between the values of the two different dates. So if I'm buying the share at 100 rupees today and selling it at 110 after a year, the profit is 10 rupees. As simple as it is. We can compare that. See, 90 rupees is the expected options value at the end of 3 months, and at time 0 it was 65.85. So this was your cash outflow if you buy the option, and this is your cash inflow at the time of selling the option. The balance will be your profit. Okay. Question number 66 is exactly same to the one that we have discussed. You should take it as homework. Again, it will be like 0.50, then the probability, the value of the option, return of the option. And now the only new part is this question number 2. Let's look at this second part. In the previous question that we discussed, there were only 3 parts, right? 1, 2, 3. But in this, there are 4 parts. The first, third and fourth one are similar to the previous one, so I'm not considering that. Now, explain how the investor will be able to maintain identical position regardless of the share price. So, the answer to the first part is, for perfect hedging, we need to buy 0.5 shares and sell 1 call. Okay, have a look on the second part now. How the investor will be able to maintain his position if he purchases 0.5 shares and writes 1 call option. If he is the writer in the option, then the premium is the only profit to him. Otherwise, there will be a loss. Okay. At time 0, buy stock 0.50 into the current stock price, which is 650. Current spot price is 500, and you sell option. So you are selling the option, that's 250. You will have to pay and you will receive 65.48. Why you will receive 65.48? Why you will receive the premium? Because you are seller of the option. Okay, sir. Now, what are the two prices? 780. No, just a second. The two prices are 650 and 450, and the strike price is 550. Okay. What, let's say after, at the expiry, it goes to 650 or 450. Now what will happen to both the situation? You have bought the stock, right? 0.50 stock, you sell it. Sell stock. How much? Only 0.50. So half of this will be sold by you, half of this will be sold by you. You will receive 325 in this case. You will receive 225 in this case. Am I right? Because you are only selling half of the stock. So this position is closed. Now you had a sell option position. So you sold the call option to someone else. Someone else has the right to exercise, and he will exercise only when it's a profitable situation to him. So you can see that call option will get exercised here, but you are the writer and you will have to pay the difference amount to the buyer. So 650 is the price. What will be the difference amount? 650 minus 550. Am I right? 100 rupees will be a loss to you in the options contract, because when you sell the option, the only profit to you is the premium amount, which you have already received at time 0. So if there is any cash flow at expiry in the option, it will only be a loss. Otherwise, it will be 0. You see that the other person who is the buyer of the option will exercise this option because the today's market price is 650 and he can buy from us at 550. A 650 item he is buying from us at 550, so obviously there is a loss to us, which is 100. But a 450 item will not be bought by him at 550, so he will ignore the call option. Ignore the call option means he will not exercise the option and the cash flow will be 0. And you can clearly see that in both the options, in both the situation, your net cash flow is fixed at 225. So you are going to receive 225 for sure at expiry, no matter what the price is, because you have created such a situation that the cash flow at expiry is same to you. And what was the investment in the beginning? 250 minus 65.48. So the investment in the beginning was 184.52. At the investment of 184.52 in the beginning, you made sure that the price, that the cash inflow at expiry is 225. So the profit is for sure. Now you can clearly see there is a difference in these two prices, and this is nothing but the profit to you. What is the profit? Return 225 minus 184.52. That's 40 rupees 48 paisa. You ensured in the beginning itself that your profit will be 40.448 paisa. Understand? You bought the stock, and this everything came up from with the simple example or the simple formula of this delta. You first calculated the delta and you found that in order to create a perfect hedging situation, you need to buy 0.50 stock for every one call option. So if you buy the stock and write the call option, you have to do it in this combination. and this combination has ensured that you get the same cash flow at expiry, that is, just a second, that is 225. You can clearly see that at expiry, no matter what the price is, the cash flow will be 225. So you are ensured. Invest to 184.52 and get back 225 rupees. That's your win-win situation in all the cases. The only thing is you should know how to create this portfolio in real life as well, to make sure that you earn at the end of the day. By investing 184 rupees, if you are earning 40.48, nothing's bad in that. In just 3 months. So do you understand the situation? Rest everything is same. So let's move on to the next question now. Okay, question number 67 is based on the swapping concept. Let's do one thing. We will just postpone this question. Why? I will tell you. Because we have to discuss about the entire swap concept. And the swap concept is better discussed in the interest rate risk management chapter. I have to discuss the same there as well. So instead of wasting time twice, it's better to discuss it in the same chapter, interest rate risk management. And after doing that entire discussion in interest rate risk management chapter and solving some questions, I will come back and solve this one. And at that time, you will feel that, okay, this is so very easy now. With this, we end this chapter of question number, after question number 67. Okay. There are 2 more questions left in the options. And let me just go to that. What was that? Yeah. The very first question was this. Have a look. Question number 15. Let's just complete that. On 3rd June 2011, option with a series of CE. C means call, E means European. We have discussed both of them. Reliance Industries Limited 250 is the lot size. 1000 is the price. July is expiry. So this is how it is presented. Is sold by Mr. Avinash at a premium of rupees 12. So he might have received this much of the premium. And spot price of RIL is 980 per share. He sold the call option to someone else. If the initial margin deposit is at 20% of the transaction value, then find out the mark to market margin for the following dates. Understand? How many contracts? Okay. 250 multiplied by 1000 into 20% will be the initial margin, because 250 is the lot size. One option is for 1000 rupees. 250 are the total options in one lot. So this is the contract value. Multiplied by initial margin is 20%, because you are the seller of the option. Buyer of the option has to pay the premium and seller of the option has to pay the deposit, initial margin. The deposit is taken only from those people who can default at expiry. So in option, what happens is that the maximum expense of the buyer is only premium, right? So there is no need to, and which is being paid by the buyer at the very beginning itself. So there is no risk of default from the buyer of the option in options contract. What used to happen is that, let me just explain this to you. In futures, buyer and seller both can have loss at expiry, right? That means both can default at expiry. That's why both were expected to pay initial margin. So both had to deposit the initial margin in futures. But what happens in options? If there is a buyer, there is a seller. At expiry, either there will be a zero profit or loss to him, or only profit. So buyer will not have any kind of a loss at expiry, but the seller will only have either zero or loss. So only the seller is the person who can default at expiry, and that's why he is only required to pay the deposit amount in the options contract. In case of buyer, he pays premium, which is the permanent expense to him at the beginning. No need to take, no need to receive any kind of a deposit from the buyer, because he is not going to have the losses after this premium. But he can have only losses, and the chances of default is high in case of the seller of the option. That's why seller is required to pay the initial margin. That is what is the question is about. Avinash is selling the options contract to someone else. That's a European call option. That means it can be exercised only at expiry. Okay. Avinash at a premium of 12. So the premium will be received by the seller. Okay, so he will have to deposit the initial margin. The initial margin is 250 into 1000 into 20%, which comes to 50,000 rupees. So he will start with the 50,000 rupees of the margin account. Now what will happen? Just imagine the premium that at which he sold the option was 12. So he sold at 12. If the premium is going up, that's a loss to him, because he will have to buy it back. Now understand what is happening. This is what is the reality. You sold the option at 12. You are not buying it. You have sold it, and now the premium has gone up. When you sell something, you expect the value of that asset to fall so that you can buy it at a lower price. You sold the option at 12, and now if you buy it at 14, this is a loss to you for 2 rupees. 2 rupees of the loss on 1000, on 250 options. That's around 500 rupees. This will be adjusted. In your margin account. Have a look. 500 rupees loss. Because it's a loss, it has been deducted from your margin account. On the very next day, now your contract is settled at 14 rupees. Imagine now you have a sell position at 14 rupees because this is settled. If the market price goes up again, there is a loss of 15 rupees. You sold at 14, buying at 15. So 1 into 250, again 250 rupees of the loss. But from 15 to 9, you sold at 15, you are buying at 9. That means this is a profit to you. If the prices are falling, there will be a profit to you because you are a seller. So 15 minus 9, 6 into 250. That's around 1500. This is a profit that will be added to your margin account. 1500 profit added to your margin account. And then in the same way, you can go on and complete the question. By the end of the 13th June, you are back to 12 rupees at which you purchased the option. So you sold at 12 rupees, you are buying at 12 rupees, no profit, no loss. You will get back your margin account balance, which is 50,000 itself, which was the same as at the beginning because the premium is same at that point. So what happens in the options contract is the difference between the premium is your profit and loss, because options value is not strike price, it's the premium. So if you sell option, you are selling the premium. If you buy option, you are buying at that premium. That's it. This is the question, and it was, I think, easy one. Question 16 is over. Question 17 was homework. Now question number 18. This is related to open interest. So let me take a break and I will be back with this. On 1st June 2011, client X takes a long on 10 lot of put option. 1st June, client X is the buyer. So in this case, the first party is the buyer, the second party is the seller in the last column. Okay. He takes a long on 10 lot of put option. So this is long, this is put option. You need to create a table of what exactly is the question is, so that you can this all messed up things should be properly organized in a table. So on 1st June, the asset was Reliance Industries Limited. We took a long position on put option, and that too 10 lots. Okay. 250 was the lot size. After 10 lot, we have a lot size of 250. Then the strike price is 1000 and it is expiring in July. The strike price is 1000, it is expiring in July, and the buyer is X. Okay. and long on 12 lot of call option. So again, X is the same party who is the buyer. On the same date, Infosys was the asset. We are long on the call option of 12 lots. Okay. On Infosys, and the lot size is 200. The lot size is 200 written here. Expiring in June with an exercise price of 3000. See, expiring in June with an exercise price of 3000. You can clearly see that. And X. X and X is the buyer of all this. Now, the counterparty means the seller is client Y for RIL and Z for Infosys. So Y for RIL, Z for Infosys. The sellers are those. So I have just organized it properly. This entire statement is like this. Okay. Now, the second part of the question starts from this point. Till this, it was the first itself. It was all about the 1st June. So the 1st June data, the 4th June data, and the 6th June data. Okay, let's read about the second part. On 4th June, client X is the buyer again. So he is the buyer again. Okay. Then buys 6 lot of call option. 6 lot of call option on RIL for July with an exercise price of 1000 and sells 3 lot of call option on Infosys for August with an exercise price of 3200. So first of all, Reliance Industries Limited. See, 4th June, Reliance Industries Limited, we took a long position on call option for 6 lot. 250 is the size. The size is not given there, but we will take the same as it was given in the previous part. And 1000 is the price, but it is expiring in July. So you can clearly see that this was the put option with the same data, but this is a call option on Reliance Industries Limited. So both the options are different. Okay. And in the second part, in the Infosys, X is the seller. You can clearly see. So that's why we have written him on the second side. He is the seller. So Infosys, he's short. He is the seller. He took a short position in call option with 3 lots. See, 3 lot call option Infosys August. So this is call option 3 lots. 200 is the size taken from the previous part. 3200 is the price, exercise price, and August is the expiry. So you can see that this call option and this call option on Infosys is different because this one is expiring in June and this one is expiring in August. The counterparty for both of these transactions is client Y and Z. So client Y here and client Z here. Client Y is the seller of RIL call option and client Z is the buyer of Infosys call option. Okay, sir. Now on 6th June, client X again selling 7 lot of put option of RIL. Client X selling 7 lot of put option of RIL. Okay, with an exercise price of 1000, lot size same, and an expiry and sells expiry. Yeah, see, July is the expiry. You can clearly see that X was the buyer of the same option. RIL long put, size is also same, strike price and the expiry is also same. 1000 July, 1000 July. Put option, RIL. So what he exactly did is he reduced his position. Open interest was 10 lots in that. And at this point, the open interest is 3 only because he sold 7 contracts out of 10. This is the first transaction, I think. All the 4 transactions that is shown here are different and cannot be netted off with each other. Because you can clearly see that all the 4 transaction has a different expiry. 1000, 3000, 1000, 3200. Okay, the 1000 same expiry. The expiry is same in this case also, 1000, 1000, but one is the put option, the other one is the call option, so you cannot net it off, right? You can net off the transactions only when everything is same. You can buy call option, so you will have to, if you buy call option, you will have to sell the call option with the same expiry. So the option and the expiry should match. Okay, so this is the first point where you are reducing the position. Otherwise, these four were the open interest. These were adding to the open interest. Okay, then he sells 7 lot of put option for Reliance Industries Limited, July exercise 1,000, and sells 8 lot of call option on Infosys. See, Infosys, he had a long position in the call option for June. What he did is he sells 8 lot of call option on Infosys for June. So now he is reducing. This can be matched with this and this can be matched with this. Infosys short call 8 2000 and June, and the counterparty being Y and W. So counterparty, in both the cases X was the seller, so Y and W will be the buyer of the call option and the put option. Now show open interest of different parties. One by one you will have to show open interest of all the parties. This is an interesting question and there are lots of chances that you will end up making a mistake. Now when you think from the angle of the X is involved in all the 6 transactions. X is the buyer in the first 3 transactions. He is the seller in the last 3 transactions. Okay, when he is buying in the first 3 transactions, all the 3 transactions are a separate transaction. They cannot add up to each other. So Reliance and Reliance was coming here. You could say that we have taken a long position in the Reliance and Reliance, so we can add 10 plus 6. No, we cannot do that. We cannot add 10 and 6 because of this same position. Reliance long. So can we add 10 plus 6, 16 contracts? No, sir. Because of one difference, which is put and call. Both the contracts are different. So we cannot add these as well. So in the beginning, X had 3 open interest position, 10 lot of this, 12 lot of this, and the 6 lot of this. Okay, and okay, then let's come to the fourth part. The fourth one is also different. Infosys, long and short. Okay, that's okay. Long and short can be netted off. We can just deduct it, but the product should be same. You can clearly see that. I will just show you. You can match the Infosys and Infosys. You can match the call and call option. But the main problem here is, after doing this, you can say that we have taken long on 12 contracts and now we are shorting 3 contracts. That means the total contract is 8 or 9. No, it's not that. This is a separate contract. This is also a separate contract because the expiry is different. If you are buying the June call option for Infosys, in order to reduce the open interest in that, you should short the June call option of Infosys itself. You are not shorting the June call option. You are opening a different short position, or a separate contract altogether here. So this particular transaction cannot be netted off or set off with in this particular part. Okay. So all the 4 transactions are on open interest for Mr. X. Cool. Now, let's come to the 5th transaction. The 5th transaction is Reliance Industries Limited and it's a put option. So put option Reliance Industries Limited. We can match this. And 1000 strike price, July and July. Everything is matching. And what we are doing is long and short. So we can set off or we can reduce the number of contracts or the open interest. It means that the long put option or the 10 contracts of put option that we had purchased on 1st June, now we are selling 7 out of them on 6th June. So the open interest in this will remain 3. 10 minus 7. Okay, this is 3. Again, this let's compare the second part. Infosys. Okay. Short and long. That means there is a possibility, not confirmed yet, but there is a possibility we can set off both of them. Call. Good. 3000, 3000, June and June. Everything is matching. That means what? We purchased 12 call option of Infosys and now we are selling short 8 call options out of that. So 8 will get reduced and the 4 will be the balance. Now you can clearly see that the other two contracts which are open for X, in which one is the long position and the other one has the short position, they will remain open. So can I say that 3 long option, 4 long option, 6 long option and 3 short option, these will come under the open interest of Mr. X. See, 3643, 3643, RIL 3 and 6, you can see RIL 3, RIL 6, and then Infosys 4, Infosys 3. Both of them had a different expiry. That's why we cannot set off with each other. Okay, so that was all from the angle of Mr. X. Now start thinking from the angle of Mr. Y, because we have to find out the open interest for each of the parties, right? So let's consider the transaction of Mr. Y, Mr. Y and Mr. Y. So these are only 3 transactions. If out of these 3 transactions we find a similar transaction, like we find that we are selling the same thing and buying the same thing, then only we can set it off. Or if we are buying the same thing again, then we can add it up. Okay, so either we can subtract or add, but the contract should be same, the option should be same. Have a look. In both of them we are the seller, we are the Y, and in both of them we are the seller, Y and Y, but here we are the buyer. So sell position can be reduced by a buy position. Okay, let's find out first with this. This is Reliance, okay, and this is a put option. This is also Reliance, but this is a call option, so we cannot subtract this position with this position. So we can square off this position with this position. Now you can clearly see that RIL put 1000, July, seller and buyer. We have a long position and the short position. So Y sold 10 lot of put option in Reliance Industries Limited, and Y sold, just forget about this part. This position is for the first party only. You can see from this point, Y is the seller of 10 lot of put option for July, and now he is the buyer for 7 lot of put option for July. That means the open interest for Y is 3 lot of put option, and that too short position. 3. That's it. This is over. This has been squared off with the previous position, and this will keep open. So we have a short position in this and we have a short position in this. So in under Y there are 2 open interest, 2 contracts under open interest, 3 contracts for the Reliance Industries Limited and 6 contracts for the Reliance Industries Limited call option. One for the put option, another one for the call option. So see, Y, Reliance, short. He has a short position in both, and 3, 6 put call. Although it is for July, but it is put and it is call. So both will remain open. Now think from the angle of the Z. This is a difficult question. It's not that easy, man. Z, that's it. Okay. Infosys, call, June, August. That's it. We cannot do the total or subtract it from each other, because both the contracts are different contracts. One is expiring at June, another one is expiring at August. All the 12 and the 3 position will remain in open interest. 12 and 3, June and August, open interest. And the only party left is now W. He has no other transaction, so this position will remain open for 8 contracts. 8 contracts, that's it. We had to show the open interest. That means if it is possible to reduce the number of contracts similar from the same type of option, you should do that. Or if we are adding more to the same type of option, we can do that. But if it is not matching, it will remain in the open interest. So this is how this question was. Question number 18 is over, and with this we are done with the derivatives chapter. You can see that we have covered most of the part of it from the chart as well. So a lot of part is covered under the formula, the theory. So what is the meaning of derivative? What is the importance of derivative? Who are the users of the derivative? What is the difference between cash derivatives and cash and the derivatives market? Then there are types of derivatives: forward, future, options, and swaps. Swaps will be discussed later in the interest rate risk management chapter. We discussed first about the forward and futures. So if we talk about the forward and futures, you can see what is the meaning of basis. Spot price minus futures is the basis. Okay. And if this is negative, it will be a contango market. If this is positive, this will be a backwardation market. What do you mean by the going long? What do you mean by going short? Then what is initial margin? What is maintenance margin? What is mark to market? We have seen the questions on all of this. Then we discuss about the formulas with normal compounding, multiple compounding, and continuous compounding. Normal compounding 1 plus r, multiple compounding 1 plus r by n to the power n by nt, and continuous compounding is this. Hedging with the futures is value to be hedged multiplied by risk to be reduced. Remember that. Don't take the beta here. Futures contract divided by the contract value. Then the difference between the forward contract and the futures contract. There is one major drawback in the forward contract, which is the default risk, which is removed by the future contract. There is no initial margin in the forward contract, but there is an initial margin in the futures contract. This is the traded on over the counter market anywhere. This is traded only on exchange. There is no limit for the assets to be considered under forward contract. There is a limit under futures contract for the assets to be bought and sold. Everything is standardized in the futures market, but everything can be customized in the forward market. Okay, sir. Benefits of trading in the index future. Okay, that you can read by yourself. Then we started the discussion on the options contract. See, option can be bought and sold. Who the buyer of the option is called as holder of the option. The seller of the option is called as writer of the option. The buyer of the option has two different rights. He can buy the call option or put option. Whatever option that he is buying, call option is the right to buy, put option is the right to sell. Whatever option he is buying, he has to pay the premium to the writer of the option. So premium can be calculated. The valuation of the premium has a different factors, and those factors are nothing but the stock price, exercise price, time to expiration, expiry date, volatility, that is standard deviation, and the interest rate. Based on this, the options value will go up and down. But what are the methods of calculating practically the valuation? The very simple method is S minus K, spot price minus strike price. We are going to invest in the option only if we are going to receive that much amount at the expiry. So that becomes the theoretical price. But a better version is to calculate the discounted price. So binomial model is one of the model where we discussed about whether the price will go up and down, and at every node we are going to decide whether we are going to exercise the option or not, and accordingly we'll calculate the options value. Then we discussed about the technical model of options valuation, which is Black and Scholes model, under which we learned about this formula. Then we also discussed about the put call parity theory, that okay, if we create this type of a portfolio, and then we create the other type of the portfolio, both gives the same cash flow at expiry. So it should, the investment in both of the portfolio at the beginning should also match. Accordingly we can calculate the put options value if the call options value is given to you, or if the call options value can be calculated if the put options value is given to you, provided the put option and the call option should have the same strike price. Then only put call parity theory is applicable. Okay, sir. Then we also discuss about in the money, at the money, and out of the money options. When it is profitable, whether it is call or option or put option, just understand the logic. When it is profitable to exercise the option, the situation is called as in the money. When there is no profit or loss in exercising the option, it is at the money. When you will suffer some losses, or you will have to bear the losses if you exercise the option. Obviously you will not, but if you do, it will be a loss to you, then it will be a out of the market situation or position. Then this is all theory. Then options payoff we have discussed. Options payoff for call option is nothing but maximum of the zero or the spot minus strike price. Okay, the difference between futures and options contract. We discussed this part also, American and European option. Okay, call and put option. This is one thing, covered and naked. We'll discuss it later on. Okay, sir. Most of the part, like 90-95% of the part in the derivatives analysis has been discussed by us. If you want to cover up entire thing, please go and read the theory of the derivatives from the volume 3. It is not covered in the fast track batch. That's why I'm not covering it up. Otherwise, there are few more things in the derivatives to read. A reading, one time a reading will give you a lot of clarity on the derivatives chapter. I know this is some technical chapter, there is some technicalities in that, but it is very easy to score once you understand the things, because the questions are not that difficult to solve. Okay, we'll see you in the next chapter with interest rate risk management. Bye bye, sir.
No one ever tells students why they should write something. Well, why are you writing? Well, you need the grade. It's like, no, you need to learn to think, because thinking makes you act effectively in the world. Thinking makes you win the battles you undertake, and those could be battles for good things. If you can think and speak and write, you are absolutely deadly. Nothing can get in your way. It's the most powerful weapon you could possibly provide someone with.